back to my channel. Today we're going to be finally diving back into the series and doing user-defined functions. So let's just get started and dive on in. If you need the code for this episode, it'll be in the description down below. So let's get started by first defining what the syntax for functions is going to be in our makeshift language. I decided I'm just going to do the fn keyword to denote the start of a function. The name of the function will go after, and in this case it'll be add, and then we'll have an arguments list where we'll pass the parameters. So for example, x and y, and then we'll open up braces and we can do whatever we want here, like let results equal x plus y, print results, and then I'm just going to pass back results like so. So since our language implicitly returns the last evaluated element in a block, this would be valid just by doing this. So let's now go ahead and actually get started by implementing this. First starting with the lexer, right? So what we want to do is make sure we actually have a keyword specifically for a function. So I'm going to do the fn keyword, and this is going to be just fn. Now let's go ahead and make sure we also have everything we need. We need commas for comma separated lists, parentheses. It looks like everything else is perfect, so that's good. Let's now go into the bottom of our lexer and just really quickly make sure that we add in the token. One second, there we go. Fn is going to be a token type.fn. There we go. Okay, so that's it for the lexer. Let's now move on to the AST types and come in here, and right below variable declaration, I'm going to create a new type for function declaration, like so. Because again, this is going to be a statement, so syntax like this, like const foo is equal to, this isn't going to be valid because this is a statement in itself. You could make it valid, but you'd have to define a function as an expression for that to work. So we have variable declaration. I'm going to come down here, and right below the variable declaration, I'm actually going to copy this and change it to be a function declaration. Change it in here as well. And we have a few things, right? We're going to need the parameters. Now the parameters is simply just an array of strings, right? When you declare a function, it's a string separated array. Since we're in a language that's 100% dynamic, there's no like, I don't have to put that this is a number or whatever. Neither do I have to do that here, right? This is just going to be a string separated array. So that's perfect. This is going to be the parameter list. Then we also want the name of the function, right? I mean, that's really important. We need to know what the name of the function is so we can define it in a local and global scope. And then lastly, we need to know the body. And the body right here is just going to be a statement, right? So the body of a function is simply a statement like so. So this is all we need actually for a function. Now, if your language has extra keywords that are like really important, right? Like maybe in between here, you wanted to define that this function is like asynchronous, right? Or maybe you want to define that here, like this is an asynchronous function. Then you can hold on to those values inside of here, like async would be a Boolean, right? In fact, if you look at the JavaScript syntax, there's things like arrow, which is a Boolean. And this will state whether this is an arrow function or an anonymous function, all those kind of things. For now, though, we're going to keep it really simple and just define a function declaration like so. Okay, so that is almost it. Now we just had to define the parser rule for this statement. So I'm going to come up here, and right below variable declaration, I'm going to just add in our function declaration, right? We got to import it. Okay. And then inside of the statement, right, we have a check. We have a check for a let and a const where we parse variables, and we also want to have a check case for token type.fn, right? We want to be able to handle function declarations. So we're going to do return this dot parse function declaration like so. And I need to see if I can quick fix change spelling, declare method, declare, yep. So we're going to declare the method right here. And here is our method. So that's perfect. Let's now go ahead and actually implement this, right? So we know at this point in time, if we've made it right here, we know for a fact the current token, the token we're at, is of type function, right? Like just like when we're here, we know that the token is of type const or let. So let's come in here and let's just eat that token. So let's just do this dot, we will do eats, which just eats the token, eats fn keyword. Perfect. So we've eat the keyword, right? Now what we need to do is actually get the name. So we're going to do const name is equal to, what we're going to do is this dot expect, because we want to expect a token of the type. So we're going to do expect, and we're going to do token type dot identifier, right? Expected, expected token function name following fn keyword. And I'm going to just get the value like so. So this will double check that we have the name of the function and throw an error if it doesn't exist. Okay, so now what we need to do is we need to handle the arguments list. And this is tricky because we don't want them to be args like in the call expressions where it's an expression array. We instead want a string array to handle. So we're going to do const args is equal to this dot parse, and we have a parse args function, which returns an array of arguments. Now, just in case you don't remember what this function does, I'm actually going to come in here and go to definition, and we can see it expects a parenthesis, and then we read in the arguments until we get to the parenthesis, right? So it's just going to read in and parse the argument list, which parse argument list simply just reads comma separated arguments. However, according to our AST, we're not trying to pass args, right? Arguments are a runtime semantic. We're trying to pass parameters, which is just the names. We just want to know the variable names. So at runtime, we can define them and all that good stuff. So what we're going to do, and I had to find where we were at, parse function declaration, right? What we want to do is we want to map over all of these and just double check that they are all strings. So we're going to do const or params is equal to this dot args args, not this, sorry, args. Actually, we'll just do this. We'll set it equal to an array like so. And what we're going to do is we're going to say it's a string array like so. And what we're going to do is we're just going to do a const for loop arg of args. And we're going to just double check that the arg, right, which is an expression, has the type of identifier, right? So we're going to do if arg.kind is not equal to, and we're going to double check that it is an identifier. They all have to be identifiers, right? If it's not an identifier, we're going to throw an error. And we're going to say expected inside function declaration expected parameter to be of type string. I don't know, something like that, right? And we could log the actual thing, and that's just what I'm going to do. I'm going to log the argument like so. Okay, and then we're just going to do params.push arg dots. We'll have to destructure this, it looks like. So we'll do arg as identifier dot symbol like so. And there we go. This is going to actually push the arguments into the parameter list, right? So now we'll have a valid parameter list. So if we look at what our code is, at this point in time, we've already parsed all of this, which means now all we need to do is parse this right here. So that's really cool. We actually already have that handled as well, right? If you remember, inside of parse statements, let me see what we did for parse statements. Yep, so let's go ahead, and now we're going to do a this dot expect. We're going to expect a token type dot. We're going to expect a open, is it open brace or bracket? I always get these confused. I think it's brace. Open brace, open brace, open brace. 1 second. I always forget which one's which. Let's come in here. What is a bracket and what is a brace? This is open brace. Phew, I got it. Okay. So expected ick function body declaration, right? So we're going to expect the body, and then we're just going to do a while. Actually, I'm pretty sure we already have, let me look up here real quick. Pretty sure we already have a block expression, do we not? No, we don't. Okay. So what we're going to do is we're going to come in here and we're going to do a const body, like that. Body is equal to. We're going to give it an empty array. We're going to type it as a statement array, like so. Right? So this is going to be the actual body. What we're going to do is we're just going to do a nice little while loop. So we're going to do while this dot at dot token type is not equal to EOF, I think it is. Well, this dot at dot type is not equal to token type dot EOF, and this dot at dot, it's a function dot type, it's not equal to token type dot close brackets. And we'll do a const, actually we'll just do this dot body, not body, this, sorry, body dot push this dot parse, and we're going to just parse a statement, right? Parse statements, like so. So we're going to be pushing on to the statement. We're going to continually parse and parse and parse, and then we're going to do this dot expect token type dot close brace, closing. There we go. Right, so now we have everything we need, except, right, we've parsed, at this point in time, we've gone ahead and parsed the name, the function, the arguments, and the entire body now. So that's awesome. Now all we need to do is just construct the type. So const function is equal to, I guess we can't call it function, we'll just call it fn, is equal to, it's going to take in the body, the name, the parameters, and the type is a function declaration, right? There we go, as a function declaration, like so, is equal to body is a statement array. Let me just double check the AST. So we expect a kind to be function declaration, body to be a statement array. Let's see, conversion of type string, params is a string array, type string. Is it type? Let me double check this. It's kind, so that's why. And there we go. Now all we have to do is come down here and return fn, like so. Actually, just kidding, there is still errors, so body, let me look at this again. Okay, parameters is a string array. Oh, parameters is equal to params. There we go. I'm just a dud. There we go. Okay. So now we have our function. Let's quickly try this out and just see if this works, right? We should at least be able to parse a function like this. And I'm going to just create the subtract function. I did not mean to. Sub takes in nothing, right? And I'm just going to copy add, paste it inside as well, just to like show that this is working correctly, right? So there we go. Just to spice it up a little bit. So let's now go ahead and try to run this. And we would expect that we'll get an error when we get into the interpreter.ts. We should see down here this AST node has not yet been set up for interpretation. So let's quickly go ahead and actually try this out. So we're going to do dino run -a main.ts. We get unexpected token found during parsing. Value is a closing bracket type 14. Okay. So let me just quickly get rid of that just real quick. Make sure it's not because of... Okay, yeah. So let me actually go ahead now. Let's look in the parser. And let's try to figure out where this happens. So it's because it's a bracket, I think. Closing bracket, bracket. Is it a brace or a bracket? Oh, wait, it's closing brace. Everything's brace. This dot, is it expect or advance? Let's see. Yep. Args, parse args, params. Cool. That looks beautiful. Let's just come in here in console.log args. And we should see, hopefully. Oh, there we go. Okay, perfect. So we get the error message we were expecting to see. We run it. We get this AST has not been set up for interpretation, right? And it tells us that there is a kind of variable declaration that we're not able to handle yet. So that's really cool. Let's go ahead, and you can see it's a function called add. It takes in an X and a Y. So we have them as a string. And we can see the body contains some other stuff. So that's really cool. Let's now go ahead and actually try to use this now and handle definitions. So now we're done with the front end side of things. We need to actually create a type for functions, right? We already have native functions added. So I'm going to go into the values. And we can see we have this native function type. I'm going to come up in here and create a function type as well. So we have native functions and functions, right? I'm going to copy this right here, like so. And this is just going to be a function value. Function value. We don't really need a make native function. Yep, that looks fine. Okay, so it's not going to have a call method, actually. Instead, what we're going to do is we're going to have the name, which is going to be a string. We're going to have the parameters, which is a string array. Right? We're going to need to know this at runtime, so that way we can build the environment. Speaking of the environment, we need to know the declaration environment, which is going to be an environment, right? We need to know where we defined this function. If we define this function here, the environment's going to be the global environment. And that's important because we need to know that so we can capture scope and provide closures. So we have the declaration environments, and then we'll also have the body, which is going to be a stmt array. And I should be able to, yep, up in here, import statement from dot slash front end slash AST, I think. Yay, okay. So we're going to have the body, the declaration environments, the parameter list, and the name. And that's all we need to create a function. So let's handle function declarations now. So let's go into the interpreter. Let's come in here and let's handle, instead of variable declarations, we'll also handle function declarations. So this is going to be function declaration, and this is going to be function declaration, like so. This is going to be as a function declaration. There we go. Okay, so now let's go ahead and create this function right here. So I'm going to go into eval statements. I'm going to copy the variable declaration, and we're going to change this to match. Function declaration. This is going to be of type function. Declaration, I need to update the imports, update imports. We'll also fix this here because the import's all screwed up. Add missing import. There we go, right? So now we can come in here and start getting this working, right? So what we want to do, okay, so to actually define a function, what we need to do is just create our function like so. So we're going to create, if we were calling the values, what do we need to create a function value? Well, we need all of these properties right here. So I'm going to just copy those real quick. And we're going to say as function value, like so. Okay, so what do we need? We need the name. Well, the name is the declaration.name. That's simple. The parameters is the declaration.parameters. The environment is just going to be env, because we're just going to capture our current environment, right? This is where we're declaring the function. So that makes sense. Next, what we need is the body. So the body is going to be the declaration.body. And there we go. This is really it for our function. And instead, it's going to be function like so. And I'm also going to come into the values and just change this from, instead of saying native fn, this is going to just say function. And there we go. So in here, we've now created a function value. So now what we need to do is, given this declaration environment, we need to define the function. So we're just going to do env.declare variable, right? What we're going to do is we're going to declare the variable as declaration.name. So this is the name of the function. We're going to declare it as fn, and we're going to give it a constant value of true, because we want to declare the value like so. And all this is going to do is then return fn. So we're just going to do return declaration var. And there we go. That's all we have to do to actually create our function. So what will happen is we'll create this in whatever scope we're running in. It'll capture the body. It won't actually execute anything in the body, right? These are all just statements. But it'll be ready for when we have a call expression. So let's now actually go ahead and try this out. It won't work, but there's only one little fix we have to do. So I'm going to come in here and just run it and see what happens, and we shouldn't get an error. We run it, we don't get an error. So that's actually really cool, right? We're seeing that we're not getting an error at all. So I'm going to do print add. Again, we're not calling it, we're just printing the value. And what we can see is we get our reference to our function. We can see that the environment it's declared in has the variable map with all the global scope, right? It has that this is a constant. We can see that the body contains the actual stuff we need. So that's really cool. Now let's go ahead and try to call it. So let's call add with the value of 10 and 4, right? If we recall correctly, actually I'm not even going to print because it prints in here for us. So let's just do const results is equal to add a semicolon, print, and we're just going to print results like here. So we should see the value result printed twice. Now what'll happen is this is going to throw an error because we haven't handled this yet, right? And there we go. Error, uncaught, in promise, cannot call function, cannot call a value that is not a function. This is a custom error message we created. So we actually can see where we need to fix this is in the expressions, right, in the evaluation. Why? Why in here? Because in here we have eval call exper. And what we do is we get the function, right? If the function type is not equal to a native function, we just throw an error. So instead, what we're going to do is we're going to change this so if the function is a native function, we'll do this logic right here. Beautiful. Then we'll do else if fn.type is equal to a function. We'll do some other stuff here, and then else, actually we don't even need to throw the else, we'll just copy this throw statements right here, and I'm going to get rid of this else if we get to this point in time right here, then we know we're not a function or that. Now what's really important here is we can't just do what we did before, right? There's no call method on a native function. So what we're going to do is we're going to do const fn is equal to, and we're just going to do I'm just going to call it func, I guess. Const func is equal to fn as function value right here, right? We just want to get the function destructured like so. Okay, what we now want to do is we want to construct the arguments list, right? It's really important that we actually are able to construct we need to construct the new environment. So we're going to construct the scope for the new function. This scope, mind you, is the scope that the function is going to have at runtime. And the parent is going to be not this environment at all, actually. It's going to be the environment of the function. So we're going to do scope equals new environment. And the parent is going to be function dot the declaration environment, right? This scope right here will inherit from the function itself, creating a closure of sorts. So now we'll have the scope. What we want to do is we want to create, right? Create the variables for the parameters list, right? We need to create the variables so that way they're actually accessible, right? If we don't actually assign x and y to this new scope we created, this would throw an error. So what we're going to do is we're going to come in here for const param of parameters. Actually, we'll do it this way. We'll do for 0 I is less than, and we're going to go into scope dot, not scope, sorry, func dot, and we're going to go through the parameter list dot length I plus plus. So what we're going to do is we're going to do scope dot declare variable, and we're going to declare a variable with the variable name of the parameters at I. So we're going to do, I'm just going to do const var name is equal to func dot parameters at I. So this should be a string, right? This is the variable name. So we're going to do var name. And the value is going to be args of said value. So args of I. And this is going to be a false. It's not going to be constant. We could make it so it's constant and you couldn't assign into the constructor, but I don't really like that. Now I am going to put something here to keep in mind to do, right? Check the bounds here, right? We know for a fact we're never going to miss this bounds, but there might be less args than the function. So we need to verify arity of function. So please do that on your own. Make sure that's correct, right? Make sure the arity is correct. Handle it how you would. Once we come down here, right, we know the scope is now populated with all of these arguments, which is good. And we have the function right here. So all we have to do is do evaluates. Actually, we'll just do a return on evaluates. What are we going to do? We're going to evaluate the func, right? The func.body. And we're going to pass in the environments of scope. So func.body is a statement array. Oh yeah, that's actually not what we do, sorry. What we're going to do is we're going to do the results is equal to an array. And we're going to say this is a runtime value, right? Runtime, not like that. So result is going to be a runtime value. We're going to do for const statement of func.body. So we're going to evaluate each statement in the function, and at the very end, we'll actually return results, right? The last evaluated statement. Whether there's a return statement or not, doesn't matter. So what we're going to do is we're going to do statement of function body. So what we're going to do is, because there could be an empty statement, is equal to make null, because there might be a chance that there's nothing in this loop, right? What we're going to do then is we're going to do we're going to do results is equal to evaluates on stmt, and we're going to pass in the scope like so. And what this is going to do is actually evaluate the function body line by line, right? Statement by statement, line by line. So that is what we're going to do. This is if we're at the type of function. If it's a native function, it's still super simple. And if it's not, then we're going to throw an error. So let's actually go ahead and try this out now. So we're going to come in here and try to run it. And that's pretty cool. We can see that we get both of our logs, right? Inside of this function, we print the results. That's why we're seeing that. I can also get rid of this right here. And we can see that we have results, and I can do results plus 5 for some, and we'll do add 10 and 4, so we should see 19 come out of here, and we get 19. So we can see that we have a scope. We can also, in here, what's really cool is we can create a function. So we can do function subtract. Actually, let's just demonstrate this by creating. We'll just have our add function stay like this, and what we'll do is we'll create a function called make adder, and it's going to return a function, right? So just to show that we can do this, and we're going to do this like so, and we're just going to do add like so. Now what's interesting is we can pass in a offsets like so. And in here, we can do x plus y plus offset. Now, what this is going to do is this is going to create a closure. So we'll create a function which we can call. So we'll call adder, right? Adder is equal to make adder. We'll pass in an offset of 1. So whatever we give our adder, right, is going to be at like x plus y plus that 1. So now we can do print, and we can do adder. We can call adder with 10 and 5. So we'd expect to get 16 here, which is really cool. So let's see if this works. We run it, and I need to const adder. I need to say that is that. And that's really cool. We have created the ability to return a function from a function. So we can just double check that that's what we're doing. We can call adder. I'm going to just pass this in right here. There we go. We can call adder, print it, and we should see that we actually get a function back. So when we call adder and we print it, we get a type of function, right? So that's really cool. Yeah, that is how you can implement functions inside of a language that is like this. Again, there's a lot of moving parts here, so if you're confused or would like any extra explanations, check out the code in the GitHub description down below. Also, feel free to join our Discord server, and I would love to help one-on-one in a Discord call or something, kind of clear up the air with any of these things. So, I'll talk to you guys in a later episode. Peace.